Okay, welcome everybody. I think we're going to go ahead and get started. My name is Ken Bednasz. I'm responsible for our application engineering team for North America. So I run a technical team that interfaces with all our partners. Partners could be our network operators, making sure we bring the right technologies and right products to market. It could be test labs, making sure we support the test labs to get customers through certified so they can deploy. It could be our customers or end users of our technology. So I'm going to spend the next 30, 40 minutes talking about LTE. We're going to review why you need to consider LTE now and why it's important to move quickly towards LTE. LTE is going to be a game changer in certain aspects, and so I'm going to review some of those key topics today so everybody has an idea of what's coming, new features that are coming down the road, which are going to differentiate LTE from legacy technologies that we all have used over the last 10 years. So just real quick on the agenda. Update you on LTE. LTE continues to be a global technology. LTE 3GPP is the de facto standard for all the different network operators around the world now. If we took a snapshot 2 or 3 years ago, there was WiMAX, there was CDMA, there were some competing technologies, and now in the present time, everybody has consolidated around LTE and the 3GPP technology. So we'll review where we are as far as statistics. We'll talk about the LTE evolution, which is really interesting because IoT is now big enough where we're getting our own standards built for us, so we'll talk about what that means. A lot of advantages of LTE, from power save mode, extended coverage areas. They're doing a lot in the specification to reduce size, cost, power, so we'll cover that. And then also about LTE versus legacy technologies. Again, we've been shoehorning IoT devices using cellular technology the last 10 years, using technology that was designed for cell phones. Now we have LTE 2.0 technology, which is really geared towards IoT industry, so we need to take advantage of these new features, and it's going to be a big game changer. So we'll cover a lot of that today. We're going to talk about LTE 2.0, which is really classified, in my opinion, as LTE Category 1, Category M1, and Narrowband IoT. Okay, so where is LTE today in the marketplace? There's almost 500 LTE networks that are available today, which is pretty much every country in the world. Every cellular network supports LTE. LTE was launched in 2010, about 6 years ago, and here we are today, 6 years later, with over 1 billion connections and subscriptions worldwide. North America is leading the charge in LTE, but the rest of the world is catching up and continue to ramp up their deployments of LTE. We're starting to see now more advanced functions happen with LTE, LTE Advanced. So moving to higher data speeds, LTE Category 6, that can do 300 megabits per second, and eventually LTE Category 9, that'll do 450 megabits per second. VoLTE is also a very key feature to eliminate some of the legacy technology that's used today to cover voice. So over 100 networks with VoLTE support today in some form or fashion, and that number will continue to grow over the next couple of years. But it's really important to understand is that LTE is truly a global technology, almost 500 networks available today, and it continues to grow. So I've been showing this slide the last couple of years, and I'll probably continue to show it because it's really interesting. It's showing the subscriptions in North America. So this is showing the number of subscriptions in Canada and the US, and really talks about what technology these subscriptions are using. So if you take the population in the US and Canada is roughly around 360 million people. When you look at the number of subscriptions out there that are using cellular technology, it's over 440 million. So what that means is there's 80 million more devices than people in North America alone. And so it's a pretty encouraging number. That 80 million is probably made up of some secondary devices like tablets and notebook computers, but the majority of that 80 million devices is really IoT devices, and we continue to see that number grow. When we sat here a year ago, I think that number was probably around 60 million more devices than people. Now this year, 9 months later, we're up to 80 million more devices than people. As far as what technologies are being deployed, it's really important to understand that LTE continues to be the dominant technology, and so this is where MNOs and the industry is going to make their investment. So as you take a look at these numbers, over half of the subscriptions in North America are now LTE based. So that you have to take a step back and say, okay, if I'm going to deploy new technology, do I want to put it on some of these legacy networks like CDMA, GSM, HSPA, where the subscriptions are shrinking, the investment from the MNOs is going to shrink, or do I want to jump to a new technology where the MNOs are going to continue to invest over the next few years, and that's LTE. So again, this is really important for you to understand from a macro level. Typically what happens once you see a decline in the subscriptions, it's a four-step process in order to sunset that network. Typically what happens is the network operators will not allow any new module certifications of that legacy technology, whether it's 3G or CDMA or GSM, for example. The second step is they will not allow any new device certifications using that legacy technology. Third is they will not allow any new subscriptions, and fourth is a sunset. And so as we take a look at all these legacy technologies from GSM is already in the final stages with some MNOs in the sunset phase, and CDMA and HSPA are starting that four-step process. So we have to sit back. We don't want to get caught in a scenario where you can't ship product. You can't activate products on the cellular network. So again, you need to understand that four-step process and where these legacy technologies fit in there. When it comes to the LTE evolution, the thing about LTE is the higher the category, the higher the data speed. So today we see a lot of devices that are Category 3, Category 4, and now Category 6 with carrier aggregation. Very consumer focused, so the top end is very consumer focused, high data speeds, anything with the display, video surveillance, router boxes, connected car. But what the revolution is a new path to the bottom side. Instead of cellular technology always trying to get bigger, faster, better, what we decided to do as an industry is take a step back and create an IoT-focused technology. And we have three different technology offerings that I'm going to talk about today. We have LTE Category 1, which is a legacy technology that's been repurposed. We have LTE Category M1, which you probably see a lot of PR and press on nowadays. And we also have NB1 technology, which is the Narrowband IoT. These technologies are really geared to reduce the size, cost, power of cellular, of using cellular, and then also it results in lower data speeds. So again, the goal is not lower data speeds. The goal is really to reduce size, cost, power, and results in lower data speeds. As far as the 3GPP technology path, I mentioned earlier how a lot of these legacy IEEE, WiMAX, 3GPP2 have all consolidated really around the 3GPP specification. There's four main technologies that we're going to address today. The legacy Category 3, Category 4 LTE technology that's been deployed for many years. Commercial deployment started back in 2010, so we're 6 years in the making for LTE, at least in the US and North America. Category 1 was repurposed, so what we see now is a lot of deployments on Category 1. Category 1 is really gaining some momentum. It's a good way to differentiate what's for the IoT market versus consumer product, leading to different price points. So Category 1 is where we see a lot of action right now. Networks are readily available because they did not need to roll out new infrastructure. Chipsets and modules are readily available because they're pretty straightforward paths to get units to market. But we're also going to focus on the bottom half of this chart, which is the new technologies that were designed in Release 13 of the specification that was released in June of this year. So those two competing technologies within the same 3GPP specification now with Category M1 and Narrowband 1. And what I'm showing here is a general timeline. What I'm showing is the specification was completed in March, between March and June of this year. Over the next 12, 18, 24 months, we're going to be in an implementation phase. It's a very important phase where chipsets need to be designed and developed to support this technology. Cellular modules need to be developed around that technology. Devices need to be developed. So that's from the device side. When we take a look at the network side, the MNOs have to get their infrastructure providers like Ericsson, Nokia, Alcatel-Lucent, Huawei, and others to implement that technology and then roll it out nationally. So again, we're in some new uncharted territories because traditionally, as an industry, we have used cell phone technology. So we've used 2G networks, 3G networks, 4G networks that were designed for cell phones, that were optimized for cell phones, and had many years of testing before they went live. When it comes to these new technologies for IoT with Category M1 and Narrowband 1, we're not going to have any buffer. We're not going to have cell phone guys out there testing this technology. So us as an industry need to take on more responsibility to make sure that we can make these two new technologies a success. And what does it look like? What's the differences between Category M1 and Narrowband 1? Why are some countries and operators choosing one over the other? And we'll get into a few of those details today. The important thing to understand that it is very fragmented. When I talk about 480 LTE networks, those 480 LTE networks support category 1, 2, 3, and 4. When I start talking about category M1, narrowband 1, there's not 480 networks that support these new technologies. They're going to be rolled out one at a time. And so we see in Canada kind of focus more a little bit on narrowband 1, where US is a little bit more focused on Cat M1. As you go into Europe, there's a mix. There's also some LoRa and some other competing technologies for LPWA that are being deployed around the world. So I'm not going to get all the specifics here, but it's a fragmented marketplace, and people are asking me, why? Why are some MNOs choosing M1 versus narrowband 1? What's the differences? And so one thing that we see from our side is depending what network infrastructure you run, so a lot of the MNOs in the US run Ericsson and the Nokia LTE infrastructure, and Ericsson and Nokia are very focused on category M1. And so we see the MNOs in US going with M1 deployments first. And then we see other parts of the world like Canada, which is heavily reliant on Huawei infrastructure, they're going down the narrowband IoT path first. So it really depends what infrastructure you have, what your core network's made out of, on which technology you're going to launch first. So the other question we get is, will the MNOs do both of these technologies? So we do feel, at least in my opinion, that there is a place for both category M1 and narrowband 1 in the same network. So over time, we do feel that this will be blended a little bit more, where most of the MNOs around the world will support both of these technologies, but that's going to take a few years to work out. The other big question we get is, what's the difference? Why would somebody choose Cat M1 over narrowband 1? In my opinion, to oversimplify it, is if you're using cellular today and deploying in volume, you probably will end up using category M1. M1 has the full mobility that you're used to, voice support in the future, IP addressing. Everything that we've come to learn over the last 10 to 15 years will be available in category M1. When it comes down to narrowband 1, it's a little bit different technology that's really competing against other low-power wide area networks, really designed for new market opportunities. So I take a look at, say, electric metering, for example. Sure, there's some cellular-enabled electric meters, but it hasn't really taken off. They've been using other proprietary technologies. I think, in my opinion, narrowband 1 is a great alternative for these other technologies. So narrowband is going to be more focused on fixed devices and new market segments that we haven't really thought about in the past. So, the title of my presentation is why we need to accelerate the move to LTE. It's because of these new technology and market opportunities that cellular is going to enable us to grow our business. So to break down timing, what does it take to launch and bring category M1 to commercial deployment? There's a few different things that need to happen. From the specification side, the specifications were released in between March and June for category M1, so specifications are done, which is a huge milestone for the network or for our industry. Second, they're working on test and performance specifications, so we need to understand how to test these new technologies. Again, we have to take it upon ourselves to make sure that we have a good network set up, to make sure we have good devices set up. Unlike the past where we really relied on cell phones, this is completely different. Cell phones will not be using this technology, so we need to take all the steps, us as an industry, to make sure we're successful. As far as the MNOs, so MNOs could be AT&T, Verizon, Sprint, T-Mobile. They are planning 4 different types of testing and field trials. You've seen all the PR launch over the last couple months about field trials happening this year, limited market deployments in 2017, and then nationwide deployments towards the end of 2017 into 2018. From a chipset side, the chipset guys are trying to figure out, what's the right chipset technology to use, how do we design for these new features that are available. So it's going to take some time to have a fully optimized chipset in order to take advantage of all the new features and new advantages that are built into this IoT specification. And then from a module side, somebody like Telit will be doing sampling of modules this year, mass production of modules next year. So what does this all mean? What it all means is if you're going to do a very regional niche deployment, if you're going to take a look at sampling category M1 to get familiar with it, you can probably do that over the next 6 months. If you want to do a big nationwide deployment, you're probably looking 2018. If you want to do a global deployment using category M1, it could be after that. Again, when we talk about 480 LTE networks, that's a Cat 1, Cat 2, Cat 3, Cat 4 networks. That is not category M1 or narrowband 1. As far as deeper technology integration, you hear me up here always talking about reducing size, cost, power. What does that really mean? How does that happen? And so I'm going to show you how the new specification with release 12 and release 13 is allowing for deeper integration. And so just as an example, I started at category 3 and 4. This is what the products that a lot of partners are using today, deploying today when it comes to LTE. I showed 2 antennas, the UICC SIM card, memory, duplexers, power amplifiers, a lot of components that need to go around that device to make it a cellular module or an end device. As we move forward in time, we have category 1, which is just repurposed. It's not really a new technology, but really repurposed for IoT to help differentiate IoT versus consumer. The components are basically the same. From a device level, the requirements to antennas, duplexers, power amplifiers, smaller memory, so maybe there's some advantages around the memory size, but there's really no technology evolution or advancements when we move from Cat 3, Cat 4 down to Cat 1. The technology evolution really happens in release 13 with the 2 on the right-hand side. So as we move to Cat M1, Narrowband 1, there's provisions in the specification to remove the duplexers, so we're removing components, making the product smaller, saving money. Removing a secondary antenna, same thing, saving some size, saving some cost, reducing memory even further, and then as we get into Narrowband 1 and eventually M1, bringing those power amplifiers potentially inside the chipset as network operators move from a 200 milliwatt system to a 100 milliwatt system. So there's a lot of technology advancements that are being made in these new specifications which will help benefit us with the years to come. As far as technology selection, I think one of the key points, one of the big takeaways today is as you take a look at what technology you need to move to, there's going to be a couple different options, and you need to take a look at what's important to you. So I have a few slides that I'll talk about on technology selection. So on the left-hand side, I'm showing the Category 1 product, Category 1 technology, I should say, commercially available now. Global coverage, which is really important for certain types of applications. Voice support, which could be very important for certain type of applications. Typically requires 2 antennas. And the right-hand side, we have the new technology, M1 and Narrowband 1, which is really focused on reducing size, cost, power. It's designed for a single antenna. So if you're size constrained, that may be the right technology for you. Extended coverage, which is really important. I have a slide on extended coverage, but it's going to increase the RF link budget to get better in-building penetration and ground penetration, kind of eliminate a lot of those dead spots we see today. So you have to make a choice, do I want a technology that's available now or something that's coming in the future, and we'll go through those different trade-offs. I also talked how using cellular is no longer a level playing field. In the past, it didn't matter if you used GSM, CDMA, UMTS, HSPA. All those technologies supported voice, data, SMS. There was no really competitive advantage one over the other when it comes to technology. They both used about the same amount of power consumption. The radio cost is the radio cost. I mean, there's not a lot of new technology advancements happening. All those technologies would wake up every 1 to 2 seconds to look for the incoming phone call, even though you weren't designing a cell phone. What's happening now with the new technology, with release 12 and release 13, is they're trying to address the battery-operated devices. One of the biggest things holding back the IoT industry was the lack of a power-efficient or battery-efficient protocol that we could use to get battery life to 1 year, 5 year, 10 years. And that's now possible with what we call PSM mode or power save mode. So power save mode is something where you can go into a deep, low power state, draw very little current, and really increase your battery life. So instead of getting 7 or 10 days out of a cell phone, you can now get 5 or 10 years out of a device, out of a sensor. So a really big step forward in our industry. And so this is one of the reasons why you need to consider moving to LTE sooner or later. You may have a tracking device and your competitor and you are saying, hey, we're within 20%. I get 10 days out of my tracking device, I get 12 days. But if your competitor comes out with a product that supports PSM mode, they may advertise they get 100 days now, and what does that do for your business? And so what we're here to do is to help educate you and provide you guys with the technology to ensure success and a competitive advantage. The other thing that's important to know about power save mode is applicable to all the what I call the LTE 2.0 technologies. It's not only Category M1 and Narrowband 1, but it's also available with LTE Category 1. The other enhancement is an extended DRX mode. Extended DRX mode is very similar to power save mode, but a little bit more elegant. The power save mode one, let me go back for a second, is really focused for mobile originated devices. So once you go into this power save mode, you can no longer be reached, so there's no incoming messages that will reach the device. And so it is really geared towards certain types of use cases where you're sending data periodically or you're sending mobile originated data. It's not really geared towards use cases to receive data. And so that came out in release 12, which happened March of last year. And with the new specification in release 13, they enhanced that, which extended DRX. So with extended DRX, what they do, instead of waking up like a cell phone every 1 to 2 seconds to read the incoming page channel to look for a voice call or text message, you now have the right to configure your own paging channel timing. So right now, instead of waking up every 1 to 2 seconds, you can do 2 seconds up to 44 minutes, which is very significant. So we're talking 1,000 times less waking up to read the paging channel. So you have significant ways to get 10 or 20 years battery life out of a device. The other big technology advancement is extended coverage. This gets really important as we start to bury devices in the ground, for example, water meters, parking decks that go underground. A lot of times today they suffer from no cellular coverage, and so the industry set out to kind of fix that. And what they did is they extended the RF link budget by 10 to 20 dB, which is very significant. What I typically say is every time you extend your link budget 6 dB, you get double the coverage, double the length. If you look at the actual area, it's larger than that. So what's happening with extended coverage with LTE Category M1 and Narrowband 1, it's a better link budget. They have narrow bandwidth, so they can have a better link budget, more robust coding, data retry techniques to really extend the reach of the cellular network, which is really important for certain types of devices. And then for technology comparison, so I think this is a little bit of an eye chart, but the point here is I want to show a couple of the differentiators between Category 1, M1, and Narrowband 1. So one is availability and timing, right? So one is available now, one is going to become available and be fragmented around the world, so it depends what you're looking to do. If you're looking to do a regional deployment or deployment in one specific country, then M1 or Narrowband 1 could be an option for you over the next couple of years. If you need to do a global deployment, probably Category 1 is going to be more applicable. Data speeds, as we get into M1 and Narrowband 1, the uplink data speeds are reduced. M1 typically advertises around 1 megabit per second up and down, but with half duplex it's closer to 500 kilobits per second. And when you get to Narrowband IoT, 20 kilobits per second uploads. The antenna requirement is really important. Category 1 devices, if you want to get the optimal coverage, still requires 2 antennas. The specification was designed for 2 antennas. When we get to Category M1, Narrowband 1, it's designed for 1 antenna. So if you have a compact device, very size limited, can't fit a secondary antenna in there, then that's a technology to consider. The other one I mentioned earlier was mobility. Cat 1 and Category M1 have full mobility, the full cellular mobility we're used to, where you can send data, drive between cell towers, and continue to send data. Narrowband 1 is more of a fixed device technology, where if you're sending data and moving, you're going to have to resend that data if you switch between different towers. Voice support, so Cat 1 supports voice today. There's some provisions to get voice support on Category M1, where Narrowband will never support voice. So if voice is a key component of your design, then you're going to have to stay on the left-hand side of this chart. Accessibility, I think this is one that's kind of hidden deep, but maybe the most important one. When it comes to the cellular technology we've been using, we use IP-based technology, SMS, voice data. You open the socket data connection to an IP address, very straightforward. When it comes to narrowband IoT, there's some different deployment models. Some of them are SMS only. Some of them are what they call more of a control plane, user plane, so there's no IP addressing. So if you're used to connecting directly to your server, that may not be possible with all the narrowband networks that are deployed. So there's a few things that you need to think about. But if you need full interoperability, you're probably going to stay closer to the left-hand side of this chart. If you're doing a regional or national deployment, then the right-hand side of the chart could make sense. As far as the different IoT segments versus technology, I think this is also a very important slide. We get the question all the time, so is Category 1 going to go away? Is Category 3 going to go away? And there's different categories to address different vertical segments depending on what your needs are. If you are a mobile computing device, a tablet, infotainment, automotive, you're going to stay on the high end of LTE. LTE Categories 3, 6, 9. If you need voice support or you need security or PERS or some kind of landline replacement, you're not going to be able to drop below Category 1 for quite some time. Where Category M1 is going to really pick up is for the people that don't need voice, that don't have data requirements. So maybe track and trace, point of sales, retail, vending, ATM, wearables. So Category M1 has a nice play in those type of vertical segments. And then the way I look at Narrowband 1 is really a new market opportunity. Talking about utilities, sure, there's cellular utility devices, but it's not mass market, it's not shipping in high volume. So I think utilities is a great opportunity. Connected building, any kind of sensoring in the building, smart cities, traffic monitoring, road monitoring. So again, what Cellular is doing is expanding the market reach into IoT. It was very niche-y over the last 10 years, and they're trying to expand it into more different vertical markets. So crossover opportunities. So with Category M1, Narrowband 1, you have a lot of the same benefits of reduced size, cost, power as you see in a lot of these proprietary technologies. So you see different proprietary technologies like SIG-SLOW-PAN, Sigfox, LoRa, and others that have had some very strong advantages over the traditional cellular market. That is now changing. With Category M1, Narrowband 1, there is some advantages for certain applications to consider cellular. What the MNOs are going to advertise and the industry is going to advertise is, the offering of, coverage and security, mobility, quality of service, SLAs. You don't have to set up your own network. So there's some advantages for some use cases where we see Category M1, Narrowband 1 kind of reaching over and going after a different part of the market that it never addressed in the past. There's a lot to be said about having coverage and network already built. My favorite story is the Amazon Kindle story. Most people know what the Amazon Kindle is. They sold it in two different versions. They sold a Wi-Fi version, and they sold a cellular version. And so the cellular version was nice because it worked out of box. No matter where you were, you could download a book and read the book. No problem. If you're getting on an airplane, if you're at your mom's house, you're at a friend's house, it didn't matter. You could download the book and read it. When the Wi-Fi version came out, the user experience was much different. You had to keep configuring that Wi-Fi connection. You send an Amazon Kindle to your mom, they can't get it connected, then they move over to their sister's house, they can't get it connected. The out-of-box experience was very poor. And so you have to take a look at what's your use case. Do you need a very easy out-of-box experience? Are you going to be shipping the product around the world? Are you going to be shipping it across the nation, or is it very regional? But these are some advantages that the cellular LTE 2.0 are going to offer. So again, it's not going to replace, it's by no means going to replace all this LoRa, Sigfox, SIG-SLOW-PAN, all these other proprietary technologies, but it is going to be another option for certain vertical markets like utilities and some of the other ones I mentioned earlier. So why move to LTE? I think we covered, I'm trying to summarize it a little bit now. Why do you need to move to LTE soon? Legacy technology lifespans is one of them. All these technologies, whether it's WiMAX, 2G, 3G, UMTS, CDMA, are all kind of funneling into LTE. You're going to get into the 3GPP standard somehow. But the lifespan's a big thing. We've seen for the first time CDMA and UMTS subscriptions declining significantly year over year. We've never seen that before. So you can see that these networks are on their kind of last stages. Now that does not mean that they're going to go away in 1, 2, 3 years. What it does mean is that MNOs are going to start putting together that 4-step plan to eventually sunset those networks. And so we have to take a look at where we are, and we don't want to get caught in one of those steps, right? You don't want to get caught where you don't have an LTE product yet, but you can't activate a legacy technology. So you really need to monitor that closely, depending on how long it takes you to get a product to market. The ecosystem and sustainability is very clear. Everybody around the world has kind of standardized around 3GPP. Typically, we would say if there's 100 commercial networks, it has enough sustainability, a big enough ecosystem to be successful. In this case, instead of 100 global networks, we have almost 500. So it's definitely a very huge ecosystem. So that helps out with everything from chipsets to components, to everything to make a successful technology usable in the marketplace. The advancements in size, cost, power. For the first time ever, we're seeing a new technology that's going to be more cost effective than the legacy technology. Typically what we've been seeing is we've seen a 2G product. In order to move to 3G, you wouldn't get any new features, but you had to pay more money. You got to put more components in the product. To move to 3G to 4G is the same way. Now with the LTE 2.0, we're actually seeing a crossover where this technology is more efficient as far as economically, size-wise, power-wise. And then the game-changing features. Again, we have to figure out as Telit partners, how do we use these new features effectively to create a competitive advantage? We want our partners to have the most competitive products in the marketplace, longest battery life, being able to work deep into the ground in the most difficult and ruggedized environments. And so we need to work together to make sure that we bring products to market that allow you to take advantage of these new features. And then trade-offs. So I think as we figure out what's the right technology for you, is it a high-end Category 3 or 4 device, Category 6, or is it a Cat 1, M1, Narrowband 1? These are the type of questions that we all need to ask ourselves. What am I looking for? Is it a global deployment versus a local deployment? Timing and availability of these networks, fixed versus mobile, voice support. Voice support for some applications is really important, and so you need to know where your end game is, and it's really Category 1 now with eventually potentially Category M1, battery powered, extended coverage. The extended coverage thing is starting to get pretty interesting because there's a lot of studies out there on how the cellular network actually covers into the sky. With all the drone activity happening, how do they project these cellular signals into the sky? What does the cellular coverage look like at 100 feet in the air versus 200 feet versus 500 feet? So it's definitely very interesting. And then we talked about interoperability, where some of these legacy technologies are very interoperable. LTE Category 1 through 4 is very interoperable. And then design decisions and challenges. So this is another one. Not only what technology do you pick, but do you need fallback technology? Do you need to roam? Is the device fixed? Antennas is a big thing. Do I use 2 antennas or 1 antenna? Banding, there's over 40 LTE bands out in the marketplace today. So these are the type of problems that Telit can help you solve. This is a real life example in the middle here, in the bottom middle, where if you're going to deploy an LTE Category 1 product in the US, for example, you can use a 2-band LTE module or a 3-band LTE module. You can use a single antenna or dual antenna. So what's the right product configuration for your use case? Do you want to be very risk adverse, 2 antennas, LTE bands, or do you have to be very aggressive on pricing and size and go with maybe 1 antenna with 2 LTE bands or 2 antennas with 2 LTE bands? So these are the types of difficult navigation questions that we can help work through with you. So I got the 5-minute warning, so I'm going to try to get through 2 more slides and then open up for a couple questions. So what's next? What's next is we do see the MNOs to finalize their LTE deployments. So we do see MNOs in the US still investing in LTE for the next 1 to 2 years to finish their network build-outs, to focus on Category 6 and Category 9 carrier aggregation. But after that point, we really see them switching over to 5G. They're going to finalize the 5G standard in about 2 years. September of 2018 is when it's set to be finalized. And it's going to focus on some areas that are not addressed in 4G, public safety, landline sunset, high density. One of the challenges with cellular networks today is if you get into an airport or a stadium, the network does not work very good. So they're going to try to address that. But I think most important for us is IoT advancements. 5G is also going to be focused on improving the IoT experience. And so what are the things that they feel is lacking today is more efficient way to access that network. Everything today with the cellular network is very scheduled. So they want some what they call grant-free access, so you can just send data up to the network rather than getting a lot of acknowledgments, scheduling the use of sending of data, and so they're going to simplify that. Device-to-device mesh. Today, cellular is not a mesh network. everything communicates back to those cell towers. So if you do run out of coverage, there's nothing you can do about it. So they're going to focus on adding a mesh component to cellular. And then, mission critical, how do they make sure, whether it's public safety or drone or other applications that are mission critical, how do they make sure they have the right provisions, whether it's latency or quality of service built into the standard? So what is Telit doing to enable success? We judge success as our partners being successful. That's everything from the M&Os to test labs to our customers to users of our technology. So from our mind, we're going to continue to be a leader. We've been a very strong leader in this marketplace for quite some time now. We have some very big success stories around Category 1, for example. We were the first Category 1 module on a lot of the M&Os networks in the US, in North America, as Mike Hewlin mentioned earlier. We were first to market for VoLTE solution on some of these networks too. So we're going to continue to be a leader. We did announce 5 new modules that are going to be deployed, sampling this year and certified next year for North America. So we're going to continue to focus on our 910 series with Category M1 and our LE866 series or 866 series with narrow Category M1. So again, there's 4 new modules that we have announced for the North American market, and then 1 for the European market with the Narrowband 1 offering. So we're going to try to build off our success and make sure that we bring the relevant technologies to market in a timely manner.